Okay, so we have w is equal to iz plus 1, and it says find w when z equals 2I. So that's actually not bad, I don't think. A part I. Find w when z equals 2I. So w is equal to I times z, which is 2I, plus 1. What's I times I? Well, it's negative 1 by definition. Negative 1 times 2 is negative 2. Negative 2 plus 1 is equal to negative 1. Okay, part 2. Find w when z is 1 plus I. Okay, now w is I times 1 plus I plus 1, which is equal to I minus 1, because I times I is minus 1, plus 1, which is just equal to I. Okay, that first part was not too bad. Next part, point Z on the Argand diagram can be transformed to the point W by two transformations. Describe these two transformations and give the order in which they are applied. Okay, all right, transformations. Let me try and draw you an Argand diagram. See what's going on. So this is the real and this is the imaginary. Okay, so two ways to kind of think of this. One, look at the two ones that we've done and try and figure out what's happening. Or if you actually look at, let's go and look at this. When we multiply we're going to multiply a complex number by I and then add 1. So if we have a complex number, z, and we multiply by the complex number I, well, I is actually equal to, it's equal to cos, because I is up here. It's like 0 plus 1I. So I is there. So it's cos, what's this angle? Pi over 2 plus I times sine of pi over 2. So when we multiply by a complex number, this is one of the geometric properties of multiplying by complex numbers. Well, when you multiply by complex numbers, it is a rotation of angle theta. So when we multiply z by this complex number, what we do is we rotate the complex number clockwise. So say it's here, we rotate it clockwise 90 degrees or pi over 2 radians. That's what that does. And then the plus 1, well, if we have a point, let's say you have a point here, and you add 1, well, the 1 is the real part. So you're literally just adding 1, so you're moving it over to here. So it's actually just a horizontal translation of plus 1. That's slightly different. Well, it's very different to a transformation in a Cartesian plane, so just be careful. This is an Argand diagram, not your normal Cartesian plane, where a plus 1 would move it up or translate it vertically. Okay, so let me just write down the answer and then I'll kind of show you how that works with these ones. What it is it's a rotation of pi over 2 or 90 degrees, a rotation of 90 degrees clockwise. You have to put in the direction and it's clockwise because this is like a positive angle. Rotation 90 degrees clockwise about the origin, and it's always about the origin, when you multiply by a complex number, followed by a horizontal translation of 1 unit. Now, yes, you do have to write all that. It says describe these two transformations, just the rotation and the translation. That's the two transformations, and that's the order in which they happen, because we're multiplying first and then we're adding the 1. So just to kind of show you guys let me just show you, I'll move this down here, how this works for these ones. So say we had 2i. Imagine z was 2i. It was up here. This is the point 2i. Well, If we rotate this 90 degrees clockwise, we end up here. And then if we add 1 in the, well, if we translate it one unit to the right, a horizontal translation of 1 unit, I probably should have said here, yeah, 1 unit to the right. So when I move this 1 unit to the right, it goes to here. Now what is this value? If this is let's say 2i, this is -2, and then adding 1, this is -1. And look, that's our -1. Similarly, if our, let's say our complex number z was 1 plus i, that would have put it here. Let's say 1 plus I would have been, let's say there. If we multiply this by, sorry, if we rotate this 90 degrees, it's going to go here, which is -1 plus I, and then, so it's going to go here, and then we add 1, which brings it over here. Translate it 1 unit to the right. What is this? Well, that's I, because it's 0 real up I. So hope that makes sense. You don't even have to draw this diagram if you understand what's going on here. The multiply by a complex number is the same as rotating it clockwise by its argument, which is the angle. Okay, finally, part C. It says, hence or otherwise find the value of z when w is equal to 2 minus I. Okay, let's do this same thing, guys. If omega is 2 minus I, sorry, w, 2 minus I, that means w is down here. It's, let's say it's 2 minus I, so it's, let's say it's around here. Now, what we've, let me just put it here. So I've gone over 2 and down 1. 2 minus I. And I'll write that 2 minus I. So remember, to get from z to w, we rotate it 90 degrees and add 1. So that means to get from w back to z, we need to subtract 1 or move it left 1, which would bring it here. This would be here, which is 1 minus I, and then rotate it, because to go from z to w, you rotate it 90 degrees clockwise. So to go from w to z, we're going to rotate it 90 degrees anti-clockwise, which would bring it here. So this guy now is -1 minus I, -1 minus I, and that's our answer. Find the value of z when w is 2 minus I, so it's minus z equals -1 minus I. And if you want to just check your answer, let's rotate this 90 degrees clockwise. There we go. And let's then add 1. There we go. That's 2 minus I. Okay, I know, guys, I made that sound like it was easy, but it wasn't. That is not an easy question. But it's not supposed to be an easy question. But it does obviously show you need to understand the how complex numbers have this property where they can be used for transformations. Okay, that's it.